This is Professor Thompson, and I'm doing again the end of exercise 35 in 1.3. So this is 1.335, and I want to point out something after you find delta, and in this particular problem, delta was epsilon. So after that, remember in class I said you have to go through the proof of showing that your delta works. And so if you look at the video that I already did, doing that part is kind of cumbersome the way I did it. And there's more than one way to do a proof in general, and there's a different pattern you can take here. And it's also the pattern that it seems that your homework uses on WebAssign, so I want to make sure that you see it. So imagine that you've done the problem and you've figured out that delta is epsilon for this case. Delta is always going to be some function of epsilon. And so what you're trying to show, your goal is to always to show that using your delta, using the fact that x minus a, whatever a is less than the delta that you chose, you want to show that f of x minus L in absolute value is less than epsilon. That's always your goal. And what I did is I went straight from x minus a is less than delta and constructed f of x minus L is less than epsilon. Another approach is to start with f of x minus L and just keep working at it, and then when you need it to become an inequality, you introduce your fact about x minus a being less than delta. So in our problem, f of x is x squared plus x minus 6 over x minus 2. Our L is 5, and our a is 2. So we're starting the fact that x minus 2 is less than delta, which was equal to epsilon. So we can really already say that x minus 2 is less than epsilon, because we chose them to be the same. So what I'm going to do is I'm just going to begin, I'm doing the proof now, I'm not doing the beginning part, but I'm just going to go from, I know that delta should be epsilon, and I'm going to just start with the expression f of x minus L, and I'm just going to keep changing it until it's less than epsilon. So I'll kind of justify each step. So mostly it'll just be algebra, but then when we need to change to an inequality, our justification is the fact that we're assuming that x minus 2 in absolute value is less than delta, which is equal to epsilon for this problem. So let's start with that expression f of x minus L in absolute value. This is x squared plus x minus 6 all over x minus 2, and then I'm subtracting 5. So now I can do some of the similar work I did when I was finding delta. I'll do a common denominator, because right now, remember, this is just an expression I'm manipulating. So the common denominator is x minus 2, and that'll make the numerator be x squared plus x minus 6, but now minus 5x plus 10, because I have to distribute that negative. And that's all over x minus 2 in absolute value. So again, these equalities are just changing the same expression over and over. And now I want to simplify that expression. And the numerator becomes x squared minus 4x plus 4 over x minus 2. And I can factor the numerator as x minus 2 squared over x minus 2 in absolute value. So now let's go to a new page. So I've got x minus 2 squared over x minus 2, and remember, I'll talk more about this later, but in limits, it's not an issue that you change the expression, because we're just figuring out the value of the expression. Remember, we're taking the limit as x approaches 2, so x is not going to be 2 for what we're concerned about. So the fact that we're going to cancel here won't matter. The whole at 2 is irrelevant because we're not approaching 2. We're approaching 2, we're not going to equal 2. So I've changed that expression, f of x minus L, I've simplified it down to x minus 2 in absolute value, but that is exactly the thing that we're assuming is less than epsilon, because we took delta to be epsilon. So that was all algebra, and this step here, this saying, okay, it's less than epsilon, this is by our assumption that x minus 2 is less than delta, and our choice that delta was equal to epsilon. So the proof works by assuming x minus 2 and epsilon value is less than a certain delta, and we chose delta equals epsilon. And so because we start with that assumption, we can just go ahead right here and say, well, x minus 2, we already assumed that that's less than epsilon and epsilon value. And that completes the proof there. So this is a lot simpler than the way I did it on the previous video. And this is the method that you'll see on WebAssign.